Step 4, I can add, subtract, multiply, divide, and factor polynomials and multiply radicals. What a mouthful. There's a lot happening in step 4. Consequently, we've decided to break down this step into about 4 parts. So the first part, the first video today, we're just going to focus on adding, subtracting, and multiplying polynomials. Then we'll have a video just dedicated to dividing polynomials. Then we'll have a video just about factoring those polynomials. And finally, we will have a video just about multiplying radicals. We're breaking it down into 4 parts. So let's start with just the first part. Operations on functions. I really like that this step follows step 3 because a lot of what we're doing to start with is just what we did in step 3 with our polynomials and our properties of exponents. For example, it's just a little bit of new notation here. If we have the function f plus g of x, that simply means take the first function, f of x, and add it to the second function, g of x. Over here you can see if f of x is 2x and g of x is negative x plus 5, if we want to add them, we're just putting f of x first and we're putting g of x second. And then we're combining like terms. When we want to subtract them, we're literally taking f of x and we subtract g of x. We're going to have to distribute that negative. When we multiply, we're just taking the first function and multiplying it by the second function. Again, stuff that we did in step 3. And finally, when we divide, we're simply placing the f function, f of x, on top in the numerator, g of x on the bottom, and the only thing we have to consider is a domain restriction, but we'll get to that in the second video. Let's take a look first at adding and subtracting these functions. So as you can see, when I want to add the functions, I'm going to take f of x and I'm going to add it to g of x. And when we're adding, we just replace and write them out. We don't need to use parentheses. We just add g of x. Now we just need to put our like terms together. You can see there's only one x squared. You can see there's only one x term, which is 2x. But there's 2 constant terms, negative 4 plus 1. When I put those together, I get negative 3. That's my answer. Go ahead and try example 1a on your own. Did you end up with x squared plus 8x minus 4? Excellent. Let's talk about subtracting. This is going to be a little bit different. We're going to still start with our f of x, which in this case is x squared, take away 4, and then we're going to subtract g of x. So we always want to use good notation, which means subtract, open the parentheses, and then we write 2x plus 1. The first thing we have to do is distribute this negative throughout the second set of parentheses. Excuse me, our only set of parentheses. I suppose I could put parentheses on the first function if I really wanted to. I need to distribute. So x squared minus 4, change the sign. Change the sign. I'm just changing the sign of every term in the parentheses, of every term that's part of g of x. And now I'm going to look for like terms. X squared doesn't have anything like it. Negative 2x doesn't have anything like it. And finally, the 2 constant terms. Again, right here I need to take f of x, which in this case is x squared plus 5x, take away 2. and subtract g of x. Now, after a while, you might get the hang of just changing the signs of every single thing in the g of x function. So I'm going to change it to a negative 3x, positive 2. Again, if you want to put that step before it, that's fine, where you subtract 3x, take away 2, and show that you're distributing. But after a while, you might get comfortable just writing the opposite signs for that second function. I only have one x squared term, I have two terms with an x, and I have two constant terms. So altogether, I end up with x squared, 5x take away 3x is 2x, and these 2's cancel out. Negative 2, positive 2. I don't even need to write anything else. Here's another way to look at adding and subtracting polynomials. Notice we have the negative that is changing the sign. We went from positive 2x to negative 2x, positive 3x to negative 3x. Negative 1 becomes positive 1. Then they group the like terms in a parenthesis. They group the x terms in a parenthesis, and they group the constant terms in a parenthesis. That's one way to think about it. Another way to try to do this is to do this vertically, where you write the first polynomial, and then you line up the like terms beneath that first polynomial, and you add vertically. You add the x squared terms. You add the terms with an x. You add the constant terms. Try to find a way that's most comfortable for you and stick with that way to be consistent. Multiplying functions and polynomials, we did a little bit of this in step 3. We just didn't use this notation. F times g of x is the same as f of x times g of x. F of x in this case is x squared plus 7x plus 12. G of x is 3x, take away 4. So we just write these side by side. X squared plus 7x plus 12 multiplied by 3x, take away 4. Again, there's lots of options for multiplying these. Some people really like to take that binomial, take the first term of it, multiply by each term, then take the second term, multiply by each term. I prefer to keep mine organized in a box. It's what's worked best for me for a while. So I draw my box. I have a binomial times a trinomial. I already noticed I made my box too big, so I'm going to shave off a little bit of my box. It only needs to be 2 by 3. I made it too big. So I'm going to put 3x, negative 4, x squared, 7x, and 12. Going across the top. And then I multiply. 3x times x squared. Think about those properties of exponents. That gives us 3x to the third. 3 times 7 makes 21. X times x is x squared. 3 times 12 is 36, and the factor of x comes along. Negative 4 times x squared is negative 4x squared. Negative 4 times 7x is negative 28x. And finally, negative 48. So we can take these terms right out of the box. I'm just rewriting those terms side by side. And now, just like we did above, I'm going to combine anything that has a cubed component. I'm going to write anything that has a squared component. These two can go together. And right here from the box, those two combine to give me 17x squared. I'm going to combine anything that has an x term. These combine together to give me 8x. And then finally, I've got a constant over here, negative 48, for my final answer. Some of these problems came straight from our Step 3 notes. Some of them we did, some of them we didn't do as examples. Go ahead and pause the video and practice multiplying these polynomials and then check your answers. Okay, here are our answers. For the first one, n cubed plus 6n squared plus 2n take away 12. For the second one, after everything cancels out, x cubed minus 64. Notice I didn't use a box for this one. I just did it by multiplying the first term by the trinomial and the second term of the binomial times the trinomial. And finally, 6x cubed minus 14x squared plus 19x minus 5.